My friends, welcome to my channel. My name is Firoz Rashid and I feel comfortable in introducing myself as a handyman. Today I want to talk about two specific features of FreeCAD, namely Lattice2 workbench and customization of part workbench toolbar. Since I am already in the spirit, let's talk about Lattice2 workbench. Lattice2 is equivalent to array feature of other commercially available software packages where we model only part of the object and multiply that several times in any given direction or directions. Lattice2 Workbench hosts some really powerful tools in FreeCAD. But today I will only cover the basics. First of all, installation of Lattice2 Workbench. So if you just installed FreeCAD 0.21, Lattice2 Workbench may not appear in this list. What you'll have to do is you'll have to go to Tools and Add-on Manager and then find Lattice2. So Lattice, it will show up. Now for me, I have already installed it, so it shows me in uninstall here. You'll have to click install on your case and it will take a second to install it and then restart FreeCAD. The workbench will show up on the list. I already have it installed a while back, so I see that I'll have to update 6 updates, so I'm just gonna go ahead and since I'm here I'll just update everything that I have. So since we are talking about adding additional workbenches, I already have A2 plus assembly and carved shapes. These are the 3 workbenches that I installed for different purposes. So I guess you will be needing them too in your work. Pretty handy. These 2 are for assembly and this is for carved. I think this is the new workbench that came in with 0.21. Could be wrong on that. I already installed a render and I haven't used that too much. I was trying to Blender actually to render things, and fastener workbench is also useful from time to time. So I would go ahead and then install all of those, since we are in the mode. And now that we have that installed, I'm just going to close it and say restart now. So we have installed Lattice2. Now we can start working on it. So I'll talk about the basics of Lattice2 now. Lattice2 makes things easier by letting you only model part of the object and then replicate it several times. Like the most frequent Lattice2 example is building a gear, where we build only half a tooth and then replicate it like 5, 10, 50 times to make it a gear. I want to start with pretty basic ones. So say I'm in the part workbench and then I just took a basic shape, say a cube. Let me go ahead and then turn on the axis cross so we know where actually we stand on this cube thing. I'm gonna go ahead and then actually sketch another thing in addition to this cube so we can make things easy. So there is that. I want to pull it up by 20. Now say I wanted to replicate these 2 objects for any given reason, and then what I can do is I can copy it. So Control C on the keyboard, or just come right click and say copy and then hit Control B on the keyboard, or say paste, either way. And so there is the replica. We already created one, and then we can go ahead and then transform it one time and we can do however many times we needed to actually. So that's one way to do things, replicate things. Like we created one cube, one unit, and then replicated that 2 times, and we can actually make it more precise when moving them sideways. Say it is 15, we want to have it 20, and the next one we want to have it 40, so that's equal distance. We can do that. So that's one way to replicate things, and then we can make the whole thing one fusion, so union, and then we can replicate it in another direction. Say I wanted to replicate it in, oh, I took the wrong thing. So I hit Control C on this. I want to copy only the fusion and paste it and then transform it. So that's one time. I want to do it again and transform it. That's another time. So now we have like an array of objects. So we built only one and then replicated it 3 times this way, 3 times that way. So we got a 3 by 3 grid sort of kind of thing. So this whole thing can be done in one, or I'm going to say 2 clicks. And that's where actually Lattice workbench comes into play. So let's go ahead and delete our work that we just did, and let's see how we can do the same, accomplish the same goal with Lattice workbench. I'm going to switch over to Lattice2, and as you can see, it has a lot of tools. We will only be using 3 or 4 of those options, and then as we grow into FreeCAD in a more intermediate or advanced level of experience, then we will be using more and more of these. But for now, today I'll be just covering the basics. So first thing first, we wanted to have an array, which is we copied in x direction 2 times and then y direction in the negative way 2 times. So that is called linear replication, or like say linear array. So in the Lattice workbench, we can have 2 types of replication, like linear array or polar array. So let's talk about linear first. And actually, these are the 2 options that we will be using more in this workbench than any other options combined. So what I want to do is I want to click on, without anything like selection, click on this linear array. It by default gives us 5 replication, so 5 units, and then a default spacing. We want to update those settings from the data tab, not the view tab. I want to work in the data tab. Selecting the linear array, we want to come and then update our count. So where it says 5 here, I'm sure we cannot update that one, that won't work. So we will have to find it from a bit. So here is top. I think that's where we were. So selecting the linear array and come to count and then update our, I think we had 3, so we will just say 3. So these units, these triangular objects, these are called kites. Kites that fly on the sky, those kites. So these 3 kites means it will be replicated over for 3 times. So we have count updated, and now we can talk about the spacing, how far away we want them, those replications to be, and we can work on that in 2 ways. So it has generator mode, span n, step n, and then 2 others. So these are 2 that we'll be using more. So span n and step n. Span means we will be deciding the span, the total distance that the objects will be covering, and then they will be equally distributed over. Step in is we won't worry about the total distance, like how far it will be covering. We will be stepping, we will be using the step from one point to the other. That's what we will be fixing it up. So let's go with span end and say we want to have span end at 100 millimeter. So from this point to that point is 100 now. So we can do that. So we come and then update the count, update the span, and then we select the object that we want to replicate. So we want to replicate the cube, and then select on the linear array and come find, this is too congested, so it gets confusing. So either of these two, I'm betting with this one. So populate with copies, that's the option that we want to go with. So we select the object that we want to replicate, and then we select the linear array, and then we come here and hit populate with copies. So that way the object will be populated 3 times because we had 3 selected as count 3. Now what if we changed it to 4 now? We changed it 4, and if you noticed, this point did not move. So when it was 3, this point is right here. I'm not zooming in, or like, let me actually bring it here. So the screen is there fixed. Now let's make that 4. What's going on? The spacing got shrunk, but the outer body, this one and this one, they are fixed in their position, and it added one more object and then redistributed the space. Because that happens because we selected total span. We fixed the span as 100 millimeters. So the span was okay, but the step changed. The spacing between these two objects changed. So we make it 5. The span stays the same. The step, the distance between one object to the other, gets shrunk over. It happens when we do the same for 2. So it's like, this span is 100 millimeter. What if, let's bring it to 3. Now what if we selected step in? Step, when we say step in, then this value doesn't matter anymore. We talk about step. So we go ahead and then say 25. So now the array is working on the step. We increase the step, the total value, the total span increases. Let's make it 35. So now that if you have a question where this step is, like how it is being reflected in our object, we can measure that. So let's go back to part and select this tool, measure linear. I want to select this point and I want to select this point. So the step, now it has 35 millimeter. I want to select this line and this line. So it is, oh, there's too many at the same point. So let's go ahead and select this point and this point, that's 25, and this point and this point, that's 35. So we have that measurement shown. Let's come back, and the step we specified 35. So the point that we are replicating, the point, the line to line, the distance is the step. It's not like the free span between this line and that line. So we got that cleared up. So when I say step, it means 2 similar points. So for this object, if we select this point, for this object, this point, the distance between those two will be the step. So that's the difference between span and step. When we select step, we worry about this value. we make that smaller, that it becomes smaller. I should have cleared this measurement, so let's go ahead and then clear that measurement. Select on this, clear all dimension and close. So even if we are not in the Lattice2 workbench, we still can work on our lattice, this array option, because that's fully parametric workbench. But let's go back to Lattice2 and see what else we can do. So on the linear array, that's pretty much it. You care about the step and you care about the span. If you select span n, you care about the span end, and if you care about the step, the distance between two similar points, then we select step and then specify the value in the step. So these are the two very important values that we'll have to update every time we use linear array. So we selected, we replicated it 3 times. I can hide this or like keep it there. What I want to do is I want to replicate that 3 more times in the negative y direction. So I am going to select that, the whole array, or I want to create another array. Okay, so I haven't selected anything. I'm just clicking on, so I created another linear array. So it's there. I hid the previous one. So this one, we will have to update the direction. I'm going to update the direction as there. So we transformed it. We transformed the array, the direction. So that's one thing. We'll have to update the direction. We want to place it to the direction that we want. And then we select on that and say count will be 3, and we select step and we say step 35. Was that 35 that time? Step n and step is 35. All right, something changed. Okay, there. So in this one, step was 20. So let's make that 20 here as well. So 20. So we got our other array. What I want to do is I want to take this array and then select this one, because we want to replicate this whole thing, all 3 of them. So we select that and then select on the new array and then say populate with copies build array. That's what we want to select there. So we got whatever that we built that time, it was built 2 more times in our direction that we specified. Now we have our 3 by 3 grid that we built the first time by copying 3 more times. So Lattice2 makes that replication easy. So if we had, say for example, we had to build a chessboard, then we can build only 1 cube and then replicate that, how many times that it takes in both direction, and then get it done. So we don't have to sketch the whole thing. We just take one repetitive part and then use the Lattice2 workbench in the linear array fashion. Inside, these arrays are there already. We can hide those, right? And the cube, the original cube is there too. Like if we hide the array and then the original cube is there, so we can hide all of these, bring this part back. I'm keeping the axis cross there to make sure we don't lose track of our center. So if we see if we can do the Boolean operation on here, we can do that. So let's take a sphere and make a cut between that, and you can see the Boolean operation can be done. What if we wanted to make that sphere a little bit bigger, say 25, so it covers the whole thing? Maybe make it a bit more in the middle. See if we can make a cut. What if we made a cut right now? Right, so there, as you can see, the whole object, the array, is working pretty good with the Boolean operation. So the lattice workbench created a fully parametric part that we can actually manipulate in other Boolean operations as well. So there, we can actually make that a union, so it becomes a solid anyway. So we can do that too. So there, within the fusion, we have a whole object. It's not an array; it's a full parametric solid. So that is all about linear array. That's what we will be using mostly. There are advanced operations that we will be doing later on, but for now, let's keep linear array at that point, and let's talk a little bit about the other array that I will be using a lot of time. That's called polar array. It's the polar, like so it's the circular array. It everything goes in radial direction. So I am going to hide this part and maybe bring another primitive. Say this time I want to take this cone. Okay, and we got this extrude. Let's come back to Lattice2 and see what we can do with our polar array. So I'm going to go ahead and then select a polar array. So it always come around the axis cross, that we have the axis of the workbench. Similar to linear array, polar array, we can select this number of kites that we have. So we can do that by coming to the data tab again, not in the lattice part. There is a number of elements 7, we cannot update that. We have to come find this count. So I'm going to say 5. We want to have 5 replication. If you noticed, not that it matters a lot, but one of the kites is always aligned with the x-axis. Anytime I replicate anything from a circular fashion, I always try to make it about x-axis. So that way, there is always one kite on the x-axis. We can do that. We can take the cone and we can select the polar array and then come to populate with copies. See, that has been replicated 5 times. So the cone has been placed on each kite on the same plane. So if you see from the front, it's on the same vertical plane, but like in the linear array, it always started from where it started. Like, you know, it was, if it was there would be 1, 2, 3, 4, 5, such and such. But in polar array, it goes around the axis, creates a circular fashion replication. That's what the polar array does. So how far, what is the distance between this point and this point, if you ask? We can find that out actually. So if you select on polar array, if you keep going down, in the polar array, in the radius, it says 25. So this polar array is replicated at 25 radius. Let's make that 0. What happened? All the 5 replications are there, but they are about the axis. So there are like 5 of replications, 1 original. There are like 6 bodies in there now. Because we made it 0, so everything is at the same point, but 5 times. Let's say 5. So now we have this, the center between the distance between this point and the center of one of the replication is 5. We can make that more, 25 as it was before. So there is polar array. Polar array has radius and it has count. It also, we can also go from like halfway to the other side. So say we select span start at 0 and span start at 360. So we have span and selected, like again, span here in polar is measured in degrees. In linear, the measurement was linear. So linear feet, linear meter, linear millimeter. In polar array, the span is measured in degrees. So the maximum span can be 360 degrees and minimum is 0 degree. So here we have span start at 0 degree and it ends at 360. Let's say we want to end it at 275 or like 270 degrees. What happened was, so between this point this and this ends at 270 degree. We make that easy and make it say 90. As you can see, all of our 5 replication is within 1/4 of the circular area. So the 90 degree ranges from 0 to 90. What if we made that 0? So all of the replications start at 0, ends at 0. So all 5 of them are at the same point. So that says something. As I said, there is always one kite on x-axis because that's where the 0 degree starts. And then it goes counterclockwise. So we make that span end because it's span mode. So we say 45. So that's 45. We have 5 replications. We make that 90. We have. What if we wanted to have all 5 of those on this side of the quadrangle, like on this side of the axis? What we do is we end the span at 180, right? And then we start the span at 90. So that way we have all of our ducks on the left side of the axis where we want it to. So if we wanted to have one on this axis, one on this axis, we could do some calculations and make it happen. So let's see, let's make it 6. Nothing changed, so it doesn't come on so it's not the count is there. It should be the span end. So the distance, the angular difference between this center and this center, which should be, so we have 90 total and we have 1 2 3 4 5 gaps. So 90 over 5 is 18. What we have to do is we'll have to add another 18 here. So plus, I'm going to say plus 18, and so that way we have now, so we increased the span so that we have 5 replications but all within the left side of the axis of this quarter of the circle. We have one on the y-axis and one on the x-axis. So we can do all of those calculations in here and then, you know, limit our work where we want it to. So that's polar array, one way to do it. Now if you noticed, our object was in the center of the workspace, so we used the radius to manipulate where it stays and, you know, it goes. I hope that is clear to all of us. We click on the polar array and then we specify the radius and whatnot, the count, and then we come and then select populate with copies. What if we have an object that is not on the center? It's a little off the center, like this object. So let me go ahead and then hide all of this. Didn't mean to delete that. I'm going to go ahead and then hide all of this, right? And then work with this. So I want to create another polar array. This time again I want to make 5 counts, and then we want to say I want to replicate this 5 times around this axis. So what I want to do is I want to select on the extrude, that's the object, and then select on the array and come here, populate with copies. Now we clearly can see that this is the original one. You can hide that one for now. We clearly can see we have 5 replications, but they are kind of like not on the kite. They are not on the kite. So previously on this one, we had all of those on the kites, but in this case it looks like they are like not. So the relation, actually we can find it out what's going on. Again, everything stays the same as span and step. Similar process, it starts from 0, goes to 360. So it starts from here and it goes to 360. It doesn't look like it started here. So that's what the question is. How can we see why it is not behaving as the way we want it to? Because the original was right here and it's not there anymore. One of the replication is not on top of that, so that could be an issue for some of us. The problem is in the radius. So previously we used radius in our advantage to take them away and move them closer. If the object is not on the center, the radius could be problematic. So in that case we can fix that in two ways. First of all, let's make that 0. So what we did, we made the radius 0. Now we have one replication on top of the original object. So everything started from that object. Now let's see, we try to update this value and see where our beginning object is. So let's say 4, 6. Did you see that? This object is always there. So looks like if an object is off the center and then we made the radius 0 in polar array, the beginning object will be where the original object was, and then it will replicate beginning with the beginning object. So we make it 2, there is that. We make it 3, there. We make it 5. So there is always one object there. So that's one way to actually handle that. The radius could be the issue where the object is not on the center. Let's put some radius in there, say 25, and we just lost it. So let's see how this radius affects our main object. I want to make it 0. Okay, I want to make that 1. Did you see how it changed? 2. Right, that's not what I wanted to do. Top, let's make that top. Okay, so we started with 0 and then say 1, 2, 3. So more we add radius in, looks like this object is moving toward axis, and then it's revolving after initially it is moved from there. So let me bring this original object back. So every time we increase the radius, this object is not moving in a circular fashion. It's taking it. So if it is 0, the original object is like overlapped with the first replication. If it is 1, the first object is moved 1 millimeter in linear fashion, and then the replication happens. So 10 means the distance between this point and this point is 10. Let's try that, see if that theory is working. So we take this point and this point. Yes, so the distance between them is 10. So every time we add a radius in polar array where the original object was not on the center, it moves in the linear fashion and then circulates. So there is that radius. So we are keeping the 25. Okay, and so the distance between this point and this point is 25. Now that we know that, maybe we can use that in our advantage when it comes. We can come in the original, so far we've been updating the original array. We can come to the populated array, and here, and then in the referencing mode we can say, so by default it's origin. We can select first item, and that fixes our issue too. So that's another way to actually handle if the object is off the center and then we want to replicate it several times, we can do that too. So if we didn't want to mess up with the radius, we can come in the populated array and select first item instead of origin. So origin makes it the radius effect. And so these are the two way that I use to actually replication and then use that in my object. So basically that's what I've been using in Lattice. There are more powerful tools in there, and then I'll talk them over time as it comes. The next actually important thing is attached placement, like where this object is not aligned. If we wanted to have them aligned with the kite, we would have to come use this attached placement. I want to make another separate video on this attachment part of the lattice, but I can actually we can go a long way without even using that, with only using linear array and polar array and then copying them, over time. So I want to keep it here, but in future I'll be expanding on Lattice2 workbench more, because this is one of my favorite workbenches in FreeCAD. Why, it's really powerful. I want to really expand on this. As I said in the beginning of the video, I want to talk also about the customization of this toolbar. A couple of my viewers wanted to know how we bring this sketch and these extra buttons in part workbench, where initially it was not there. So this is really helpful. I'm so happy that you are so observant in this part. It really helped me a lot with this sketch button having in the part workbench, so I didn't have to go back and forth with the sketcher one. Like part design has it there by default, but part didn't have it, and part being my preferred workbench, I was really mad about that. But so here is what you do: come to the empty part, right click on it and go to customize. Now it gives, as it says, customization power. What I want you to do is come to toolbar, and that's what we want to customize. And here I have part selected. So from this drop down menu, you would want to select the workbench that you're customizing. So here I selected part because that's what I use a lot of times. So part, and then maybe create a new one and say custom tools, right there. So we have custom tools in there, and so that's the right part. From the left side, it has all of these toolbars here, workbenches that I can take. I can take commands into there. So let's say select sketcher, and then we want to bring in the sketch, new sketch. So that's a lot of tools. Create sketch. So find this create, or no, just type in here, say create sketch. So there, create a sketch, it's placed there 2 times. So select the create sketch under the sketcher part. So create sketch and then move to right. So because I had this selected, it's placed under there. So if it is under there, you see it showed up right away, right away. And if you wanted to have other tools, say, what other tools that I've been using? Say part design. I want to bring in subshape binder. I use that a lot in part workbench. I actually want to place it in there in sketcher in my original toolbar. So I have create sketch, slice apart, create a clone. These are the 3 tools that I use very often in part workbench, but these tools, this belongs to sketch to workbench, this belongs to slice, this belongs to part design. So I bring them over because I use them very often. I also want to bring in this subshape object binder, sub object shape binder in here. So I want to bring in there too. So as you can see, I'm just going to go ahead and delete this one. So right click on there, customization, come to toolbar, select the part, create a new toolbar, say tool group, put some name in it, it doesn't matter, the name doesn't show up here. As long as you can find it out, that's okay. And then find all the tools that you want from the left side, bring it over the right side, and there it is. It just shows up. So those are the two questions that I received a couple emails from my viewers, and so thank you for that. I'm happy to help, and I hope this will be helpful for you. And I will keep in mind that next time, every time I use a new tool, I'll try to explain that. With that, I hope you enjoyed this video. Talk to you later.